Another one. Use partial fractions to evaluate integral 1 over 4x squared minus 9 dx. Well, what is the first thing to look for? The first thing to look for is, can you factor the denominator? Can you factor the denominator 4x squared minus 9? Well, you can. 4x squared minus 9 is 2x plus 3 times 2x minus 3. And so, the denominator is now the product of two linear factors. So this will be written as a over 2x plus 3 plus b over 2x minus 3. What is the next step? Simplify this by taking 2x plus 3 times 2x minus 3 as the common denominator and construct your numerator. What will the numerator be? It will be a times 2x minus 3 plus b times 2x plus 3. There you go. So you have constructed the numerator and we have the common denominator. And if you look, this 4x squared minus 9, the denominator on the left side, is exactly the same as the denominator on the right side. That means the numerator on the left must be equal to the numerator on the right. Alright? So equating the numerators of the left hand side and the right hand side, what do we get? 1 equal to a times 2x minus 3 plus b times 2x plus 3. Alright, what's the next step? Our aim is to find the values of a and b. That means find appropriate values of x. This is an identity. Find appropriate values of x that will reduce either a to 0 or b to 0 so that we can... Alright. Now, a can be eliminated by, tell me, I'm covering that value here. A can be eliminated by choosing x equal to what? If you put x equal to 3 over 2, then 2 times 3 over 2 will be 3. 3 minus 3 will be 0. So we set x equal to 3 over 2 in here so that we can eliminate x. You see how simple that is. So, we get 1 equal to a times 2x become 2 times 3 over 2 minus 3 plus b times, remember every x need to be replaced by whatever we choose. So that will be b times 2 times 3 over 2 plus 3, and that will eliminate this. Is that right? And this will be 3 plus 3, 6b. We got 1 equal to 6b, 1 on the left hand side, and the right hand side, this will become 0. This will be 2 and 2 goes, 3 plus 3, 6. So 1 equal to 6b or b equal to 1 over 6. Similarly, we go and eliminate b. Tell me, what will you choose as x equal to eliminate b? What value of x will make this quantity 0? X equal to negative 3 over 2. That's right. Put x equal to negative 3 over 2, you have 1 equal to a times 2 times negative 3 over 2 minus 3 plus b times 2 times negative 3 over 2 plus 3. We just replaced x by negative 3 over 2. And if you notice here, the 2 and the 2 cancels. That will be negative 3 plus 3, 0. So that term will vanish. And this will be 2 and 2 goes. It will be negative 3 minus 3, negative 6a. You get 1 equal to negative 6a. And that gives you a equal to negative 1 over 6. So we can now take the values of a. What's a equal to? A is negative 1 over 6 and b is positive 1 over 6. Alright, let's write that down. So we have a over 2x plus 3 plus b over 2x minus 3 now become negative 1/6 over 2x plus 3 plus 1 over 6 over 2x minus 3. and that is, that negative sign will make that whole quantity negative. It'll be 1 over 6 times 2x plus 3 plus 1 over 6 times 2x minus 3. Now, this is what we need to integrate originally. Now, since it is difficult to integrate, we broke it down into simpler expressions. Alright, therefore we can now integrate this. Now, integral 1 over 4x squared minus 9 dx is now the same as integral of this. Now look at the way I wrote that. That's right, integral of this, which is the sum of two functions. Which means we can integrate each of them one by one. Alright, now the first thing I can do is I can factor out a negative 1/6. If I factor out a negative 1/6 from here, this will remain positive and that will become negative. Is that right? Yes. So if I factor out a negative 1/6, alright, we are not factoring out the 1/6. We just take out the negative 1/6 from here. We are going to split this into two integrals. So that will be, the first one will be negative 1/6 integral 1 over 2x plus 3 dx. That is the first integral. Plus 1 over 6 integral 1 over 2x minus 3 dx. Now you can see I have colored them red, the denominators, because these are simple expressions we can do by a substitution. Now look on the right side, see how the substitution is made. In the first integral, we replace 2x plus 3 equal to u. So when 2x plus 3 equal to u, take the differential of each term. Differential of 2x is 2 dx, differential of 3 is 0, differential of u is du. That gives you dx equal to du over 2. So when this is replaced as u, dx becomes du over 2. And this 2x minus 3, since we have already used the u, we will use 2x minus 3 as v. And that gives you 2 dx equal to dv, or dx equal to dv divided by 2. So when this becomes u, this dx becomes du over 2. And then this becomes v, the dx becomes dv over 2. There you go. And you can actually take these 2's out. This will become negative 1/12 1 over u du plus 1/12 integral dv over v. There you go. And you can integrate each of them. Integral 1 over u du is ln of u, and integral 1 over v dv is ln of v. So negative 1/12 ln of u plus 1/12 ln of v. Of course it must be the absolute value. And plus c, well, that will be 1 over 12 ln v over u. Can you figure out how that came out? Well, you can take out a 1/12 outside, and the negative term will be ln u. Negative ln u plus ln v. Remember, ln v minus ln u is ln of v over u. ln of v over u is ln v minus ln u. And the 1/12 has come out. So it will be 1 over 12 ln v over u plus c. And what all we need to do is replace v and u. So our final result is 1 over 12 ln 2x minus 3 all over 2x plus 3 plus c. And that is the integrated form of this rather complicated integral. You see how it became simple by breaking them down into partial fractions. Alright, let's do another one.